And once again, the astronomical calendar is poised to flip to a new season. Of course, this time it's winter, starting on Friday. That gives us another chance to welcome back our good friend, Dr. Chris Palma, from the Penn State Department of Astronomy and Astrophysics. Thanks for trekking all the way over here to Walker Building, Chris.
I was happy to do it.
So I guess, at least to me, the freshest astronomy news was the landing of the InSight probe on Mars right after Thanksgiving. Maybe kind of review that mission for us and maybe have a little new insight for us? Sorry.
That's okay.
I had to do that.
Yeah. So I can absolutely understand why you're so excited, because it's going to do meteorology on Mars, right? We're going to learn some more about the weather on Mars. I think the thing to focus on with this mission, you're all very likely used to hearing about rovers on Mars, right? So Curiosity rover has driven around, but this is a lander. So it's actually in one spot. It's going to stay in one spot, because what this is going to do primarily is do some seismology of Mars. It's going to dig down to learn more about the interior of Mars, which we're really curious about. But it's also going to do meteorology. And one of the really fascinating things is we have an audio recording of the wind on Mars for the first time ever, which I thought was really exciting. One other thing I wanted to share with everybody, you may not know that we've been sending many missions to Mars. We can actually reuse technology. So one really exciting thing is this mission has a robot arm that has to reach out and place these instruments on the surface. And that robot arm was actually first built for a mission that never flew. So this is repurposed technology.
Got it. Well, on the topic of getting up close and personal with objects in our solar system, I saw over the last couple months a resurgence of exploration of asteroids. So one probe, a Japanese probe, and another one from NASA with a really clever acronym, OSIRIS-REx.
Yeah.
So tell us a little bit about that.
Yeah. So this was... There's a real lot of interest in studying asteroids, because they can tell us what the conditions were like when our solar system was forming. We really do think they're primordial, that they reflect what the conditions were like billions of years ago. And in particular, one thing we really want to learn is where was the water when the solar system formed? And one of the great results already, we've heard that one of the two asteroids, the one being visited by OSIRIS-REx, there's great evidence that shows that there are water-bearing compounds on the surface of that. So we think its parent object might have had liquid water on its surface.
And these are, when we talk about asteroids, they're in the asteroid belt then between Mars and Jupiter.
Yes.
Yes.
Yep.
Okay. So two things that our fields have in common are some great acronyms for projects.
Yes.
And also significant use of supercomputers.
Yeah.
Recently, I saw your department upgraded some of its supercomputer resources for a project called LIGO.
Yeah.
Tell us about that.
Yeah. Well, and one of the great things about that project, one of the folks who's involved has talked about, he wants to thank all the video gamers out there, right? Because the same type of technology you would use to play a video game, a GPU, a graphics processing unit, we use those same types of technology to analyze data from distant black holes. So you probably don't know, but behind the scenes, there's really significant computing resources that have to go in. So we may say, hey, we discovered this new set of merging black holes. Well, it took hours and hours and hours of supercomputer time in order to do that. And so by upgrading those supercomputers, we can learn within a week rather than within a month of what we've discovered.
And another link between our fields is that we both do research in Antarctica.
Yes.
And some Penn State astronomers have recently noticed something about these high energy particles, neutrinos, kind of going the wrong way.
So we do go to Antarctica, and in fact, we use the Antarctic ice as a detector. So we look for flashes of light in the Antarctic ice, and that can tell us when there have been interactions in the ice between high energy particles from space and that ice. So normally you would expect the high energy particles come from space, interact with the Earth from that direction, but it really looks like particles came through the Earth from the North Pole, went entirely through the Earth, interacted with the ice under Antarctica, and then sprayed particles up. And so we really do believe a new kind of particle is responsible, one that we have not figured out what it is yet.
Very interesting. Well, how about a tip or two for sky watchers next couple weeks, assuming that we meteorologists can keep the sky clear for a decent amount of time.
You've done well with that so far this week, right?
This week.
Yes. So this is a great time of year. Some of you probably heard me say before, I always encourage you to look to the southeast. If you can find the V of Taurus, you can see the really bright red star Aldebaran, and then near it is the open cluster, the Pleiades. But I want to call attention to that this time because there's a comet passing through that same area of sky, Comet 46P, and the prediction is it may just barely get bright enough over the next couple of days for people to see it without binoculars. So if you can find Taurus and the Pleiades, look for a faint blue glow from a comet.
Okay. Dr. Chris Palma, always good to see you.
Thanks
for stopping by. And we will be back in a moment with a recap of the short-range forecast.